Hi everyone, today we are going to solve the CSES problem, dice combinations, right? Let's have a read. Your task is to count the number of ways to construct the sum n by throwing a dice one or more times. Each throw produces an outcome between 1 and 6. Okay, so you have to construct n by throwing a dice. Outcome can be 1, 2, 3, 4, 5, 6. Right? Let's have a test case that n equals to 3. So there can be 4 ways to construct 3. That is 3 times 1 occurs. First 2, then 1 occurs. First 1, then there is occurrence of 2, then there is occurrence of 3. Right? So these are the 4 possible ways to construct 3. Right? So let very first you have to think about the very small problem that you are going to solve. Let's think about the very small problem. That is how many number of ways to construct 0. That is the very small problem that you have to think about it, right? Uh, for this, the number of ways is going to be 1. Why? Because to get the sum 0, you are not going to roll out the dice, right? To get the sum 0, you are not going to roll out the dice. So uh, by using this small problem, can you solve the next bigger problem, that is f1, that number of ways to construct 1? Yes, definitely you are going. Definitely you can solve. These are the outcomes, right? I have a 0. I have a sum 0. To get the sum 0, the number of ways to get the number of ways to get the sum 0 is 1. So from 0, I have to reach the sum 1, right? So there are one way. There are one way to reach from 0 to 1, right? Now, what is the number of ways to reach 0? The number of ways to reach 0 is 1. So the number of ways to from 0 to 1, there is one possible way. To reach 0, there is one way. To ultimately to get the sum 1, there is only one way to reach 1. That is the occurrence of 1, right? Now, can you give me the answer for f2? Yes, you have a sum 0. You have a sum 1 till now. From 0 to 1, from 0 to 2, there is one way. When you have a sum 1, you can reach to 2. There is only one way. Now, to reach 0, there is one way. To reach 1, there is one way. So ultimately the sum would be this. The sum to reach 0 plus with sum to reach 1 can be the answer for the f2, right? Next, when I am taking the, let's consider next step, you have clear understanding of this, right? And let's have a next case. You have to construct 3, right? So from 0 to 3, one way. From 0 from 1 to from 1 to from 1 to 3, there is one way. That there is occurrence of 2, then you can reach out to, then you can reach to the 3. When from 2 to 3, there is one way, that occurrence of 2. Here the occurrence, here when there is occurrence of 3, then you can reach. Here when the occurrence of 2, then you can reach. Here when the occurrence of 1, then you can reach. So from that number, to get the next sum, there is only one possible way, right? From 0 to 3, there is only one possible way. From 1 to 3, there is only one way. From 2 to 3, that is the constant that you have to add a unique number to reach from that. There is no two ways to get to reach out 3, right? Now the thing is, you have to add to the number of ways to reach 0. That is one. Here you have to think about the number of ways to reach 1. That is 1. Here you have to think about the number of ways to reach 2. That is 2. Right, that is 2. Then and from 2 to 3, there is one way. So how many ways totals? There are 2 ways to reach 3 ultimately, uh, right? So there is one way to reach 3. From 0 to 3, there is one way to reach. From 1 to 3, there is 2 ways to reach from 2 to 3. So ultimately for f3, the formula goes to the formula can be f1 plus f2 plus f0 plus f1 plus f2. That is 1 plus 1 plus 2, which is equals to 4, right? So this is the transitions that you can do. So let me write it in a dp form. To reach sum n, you have to 0, 1, 2 up to dp of n minus 1, right? For dp3, dp2 plus dp. For dp0, 1 plus with dp of 2, right? Now for dp1, you have to go from dp0. For dp2, you have to add dp0 plus dp of 1, right? For dp1, you have to dp plus 0, right? So ultimately it goes to dp0 4 times into dp of 0. So which ultimately goes to 4 into 1, which is equals to 4, right? So how can you code it? How can, so let's see the code. We have to take n as an input. Yep. Let's define the dp vector plus 1 comma 0. Let's define the, let's initialize dp of 0 equals to 1. Then we have to traverse from 1 to n, right? Now I have to find the dp of, suppose dp of 1. For dp of 1, I have to find the dp of 1 plus dp of 0 plus dp of 1. For dp of 2, I have to find the dp of 0 plus dp of 1 plus dp of 2, dp of 2, right? Now, so for this, I have to traverse a loop int I equals to 1, int j equals to 1, j less than equal to 6, j plus. If j less than equal to I, then I have, then we proceed, right? So dp of I equals to dp of I plus dp of I minus j. Okay, and I don't forget to take a note of this. Yes. And finally, we are going to return dp of n. Okay, yeah. So let's try to check it. Yes, so the answer is 4, right? So this is the code. Okay. Uh, uh, Now let's discuss the time complexity. So the time complexity is going to be uh, peak of peak of n into 6, right? N into 6, which is equals to peak of n. Okay. Why? Because first loop is going from 1 to n, and the second from 1 to 6, and the space complexity is going to be n plus 1, which, right? So that's the code.